Hi, good morning, everyone, or good afternoon. Welcome to the session today, part of the IBM Community Day for Data Science. And today I'm going to talk about how to get more ROI for your business by effectively combining your machine learning approaches with decision optimization. And so a brief introduction of myself. My name is Susara van Den Heever. I'm one of the program directors of IBM's Data Science Elite team. And at the end of the talk, I will introduce a bit more about our team, what our mission is, and the type of work that we do. Just a few admin matters is that I can see there are many people joining. So, okay, so I'm going to get right to it. And I have to say, I'm glad to see so many people from all over the world joining. I'm sitting in Sweden. All right, so there was a recent study by The Economist that was published, and this study stated that even though 70% of business execs said that analytics was very or extremely important to them in their business, only about 2% say that they had achieved broad positive results. And so this is not very good news for the world of analytics, and we have to think, why is that? Why? This is obviously a very important field. Why aren't people seeing the benefit? And there could be many possible reasons. So some of the reasons that were cited in that study was what you see here on the slide. So for the majority of people, they have difficulty framing exactly what's the problem they have to solve, right? You don't just want to randomly look at a bunch of data without knowing what problem you're actually trying to solve. For a lot of them, it was about the solution approach, the design that was complex. And then at the end there, you can see it was about going over to action and change management. And where I will focus today is really more towards the, so to say, we should not stop at looking at data, analyzing data, trying to understand data, or even stop at forecasting, but really get to the stage of how do you use those forecasts, the data analysis, to improve your decision-making process. And so what I'm going to talk to today, and of course this is not the only way, is how do you combine effectively your predictive analytics with prescriptive analytics, translating your analytics into actual actions. And so to set the stage for that, all of us use predictive and prescriptive analytics every day when we drive our cars. So if you think of descriptive analytics, you have your dashboard that shows you how fast you're driving, how far you've driven, and that's all good and well. But you don't really know when you're going to run out of gas. So that's the predictive analytics on your dashboard. It predicts for you what could possibly happen in the future, how far could you possibly drive. But then there's the action part, what to do about that. And that's, of course, prescriptive analytics, where today you will go on your phone or in your car and just say, what's the fastest route to a gas station or the fastest route to a destination? And so one can use this type of analogy just about for any business, where you can go from descriptive to predictive to prescriptive. And I would argue that to get most out of your business value, you need to go all the way to prescriptive. So what exactly is prescriptive analytics used for? Well, it's very much about effectively use resources, how more out of your investments and your existing resources, or how do you make better decisions with respect to acquiring new resources? And a resource can be basically anything that can be used. So anything, capital, people, products, warehouse space, number of cars, anything like that. And all resources typically have choices associated with them. So for example, how do you invest capital? How do you decide to hire people? How do you routing for vehicles? How do you decide how much of each product to produce? These all are decision problems that can be captured with prescriptive analytics or decision optimization. And so when you talk to your business stakeholders, and red flags really to tell you need to look at prescriptive analytics is once they start talking about they want to minimize or maximize a KPI. I want to minimize my cost. I want to throughput. Those are all flags that tell you, look, here's an opportunity for prescriptive analytics. Anytime when there's questions such as when, how much, where, I want to ask people to tasks, I want to find out the best route, I want to find the best trade-off. Those are also words to look out for that will tell you, okay, you're now dealing with a business problem for which analytics would be an ideal solution, or could be, I should say. All right, so that's kind of the ground. Why should we care about it? Well, prescriptive analytics, data science with optimization together are known to deliver massive ROI. On this particular slide comes from that website at the bottom of the slide, the informs.org. And in fact, I would encourage all of you to have a look at this website. Informs is an organization for operations, research, and management science. And every year they have to all kinds of industries to see which operations team or data science team can get the most ROI for their business by applying data science analytics optimization. And so these just tell you some of the winners. Not all these are IBM clients. These are people who have used various vendors. But I think the point is just to show it's across industries, and the benefits, you can see there, the numbers are quite low. Now, if you were to go and study the content of the winners, and that's something that at some point I did read all publications of the 37 winners over the past 37 years, in the majority of the cases, I would say probably 75% of the cases, the winners were combining all kinds of analytics, predictive, optimization. They were not going with one single analytics technique. They were really combining technique to insights, predictions, and actions. And in fact, if you add up all the ROI of those 37 winners, you get to upwards of $200 billion by today. So it's the point here is just to say massive ROI to be found once you combine these different techniques. All right, so how do they typically work together? So a lot of people are familiar with predictive analytics. It's very well used in the industry today. And basically, what I'm going to talk about machine learning is in that context of predictive analytics. Of course, machine learning is a lot broader than that, but today's context, I focus on this. So in this context, the principle of the machine learning is that basically you know the answer and you're training your machine how to find it. So you know some past performance, some past numbers of, say, a demand, and you're training the machine to be able to predict a similar demand. So of course, there are more advanced techniques such as unsupervised learning, reinforcement, etc. But that's the basic idea. So you have the sample data, say historic data. You can use it to train a model. The trained model gets then as input some observations of actual updated data. And from there, you get some kind of a prediction, a pattern, a classification, etc. And this is then where the tie-in happens with the world of optimization or prescriptive analytics. I should also mention I really use in this talk optimization as a key technique in prescriptive analytics, even though prescriptive is broader than that, of course. One can use rules, machine learning, simulations, all make up part of prescriptive analytics, but here I focus on optimization. So what's different with optimization compared to machine learning? In optimization, you don't actually know the answer that you're looking for, but you are teaching the machine the logic of how to find a good solution, a good plan, a good assignment, instead of a bad one. And once you get to more advanced robust optimization, stochastic optimization, which are all geared towards dealing with the uncertainty inherent in a prediction. And so the modeling looks a bit different. See on that diagram on the lower right-hand side that you have a prediction that is typically or optionally an input into an optimization model. And I'll show some examples later. The optimization model also thinks about, so this is where optimize come into the picture. So I want to minimize my cost. I want to maximize my customer service. There are some business constraints. These are all related to your limited resources. So I've only so many trucks. I need to work within these constraints. And then you have some unknowns or decisions that you can use to so it can be, how much should I produce? That's an unknown. Which driver should I assign to which truck? Which route should I take? Those are all the decisions. And then once this model is solved, it will output a recommended set of decisions or plans or schedules. Sometimes these directly get operationalized for example, in manufacturing, you just directly send those decisions to the shop floor and they get executed. Sometimes they are input to a more strategic conversation where it allows CIOs, CEOs, that level to really have a more complete picture of how their decisions, their KPIs around it before implementing the decisions. So that's basically the basic idea of how these two typically work together. And I'm going to show you a very simple example to illustrate the point of why we say predictive and prescriptive are better together. So this example is marketing campaign planning or optimization. And the basic premise here is that we consider a use case of a bank, and this bank has various products or campaigns to offer to its clients. So it can be, for example, mortgages, pension funds, etc. And the bank needs to know through which channel should it offer. Should I send an email? Should I send a postal mail? Should I have someone make a phone call? And to decide to which customers. So which customers are more likely to react to a campaign, therefore giving this bank more revenue. So that's the problem we're going to try and solve. And there are some complications potentially. So you could have hundreds of products, hundreds of campaigns, many infinite, almost, well, not infinite, but exponential possible combinations of decisions, many different channels, and many different customer segments. So it can get quite a complicated problem. In fact, we have one client with about, I think, 40 million customers. So you can imagine it gets quite complex quite fast. And so this is the problem that we're going to try and solve better by combining predictive and optimization. So put yourselves in the shoes of this marketing campaign planner. That's your job. And now, which of are you going to extend to which of your customers so as to maximize revenue, so to get the most money? Imagine that you've gone through the step of predicting how much revenue you can potentially get from each customer based on a particular campaign. So if you look on this table on the right-hand side, the first column, customers, shows you basically your list of customers. This is not number of customers, it's the customer ID. So customer number 1, customer number 2, up to customer number 10. And then you have 3 potential campaigns to offer them. You can offer them a mortgage, you can offer them a savings or a pension. And you've gone through the job of creating a prediction based on past behavior, based on their demographic, etc., to say how much money to expect by offering a certain campaign to a certain person. So if you look at this orange rectangle near the bottom, what this tells you is that if you offer a savings account to customer number 9, most likely you will get $50 or euros, 50, you will get 50 from it. If you were to offer that same customer mortgage, you will get nothing. So the problem you need to solve here, the puzzle to solve, is which offers to which customer. Now, if this was the only data you had to deal with before, you're just going to use the highest numbers for each customer. So now 6 will get pension, etc. However, it's a bit more complicated than that. Typically in the real world, there are some constraints, there are sources. And so in this case, the constraints are you can only select one offer for each customer. You can only use each offer 3 times. So imagine, for example, if the offer came from different partners and you want to be fair to your partners, you need to distribute the offers evenly. So that's a typical constraint. And then finally, you want to maximize the revenue. So what we typically say to people when we do this presentation live in a classroom setting is take a few minutes and see how good you can get. And I would encourage you to go try that offline. Try and do this assignment. And what we typically find is that while people can sometimes come up with something pretty good by using some heuristic or some greedy approach, if you're watching this recorded, I would encourage you to pause now and try to get an answer for yourself. But right now, I'll continue on to the next slide and just tell you what the answer is. All right, so the answer is the best possible revenue is 770. And so what is important is that if one were to use a heuristic approach of saying, first assign the most profitable campaign, you would not get the best answer. So in this case, if you had assigned the 150 to customer 6, you would not have achieved the same answer here. So the answer is non-intuitive, the most profitable campaign customer match, but yet your overall revenue across all customers is higher. And so this is exactly why we say you have to use predictive and prescriptive together in most cases to get most out of your ROI. In this case, if you had stopped at predicting, most likely you would have lost a large sum of money for your stakeholder. They wouldn't know it. They'd still think they use advanced predictive techniques, but that is in effect what's happening. So truly to gain that competitive advantage, once going over to optimization as well. Now, as I mentioned before, we have some clients, this was now a very simple problem, but we have some clients who have millions of customers, one with 40 million, 60 campaigns, many other different rules and constraints, and this can get very, very complex. Luckily, we have software such as CPLEX, many of our competitors as well, decision optimizers are actually very, very efficient in solving these type of problems. All right, so just a bit more explanation about what exactly happened just now. So first we were looking at how do we predict the revenue per campaign. So typically you would take some information about the client. Here we took James. We know some things about him, his gender, age, etc. We put that into a machine learning model, or use a machine learning model to come up with some kind of a score that told us how much he would pay if we offered him a mortgage, a savings, or retirement. And you ended up doing that as many times as you have clients to end up with this table. But when you had this table, you still didn't know how to do the actual assignment. And that was then the next step. So the decision optimization model then takes this bold print on the left-hand side, the prediction from the previous slide as an input. It also considers all clients simultaneously, all offers simultaneously, and it can consider all rules that you want to have in there. You solve your optimization model, and that then gives you the actual plan. So that's really how these things, predictive, prescriptive, fit in very well with each other. Okay, so I want to show a little bit how this would look inside Data Science Experience. And this is a very short demo. I'm not going to go into the detail. I think that there will be some other people today doing a more detailed demo, technical demo. I also want to point out that what I'm going to show now is available in our GitHub repository, and there's a link to it at the end of this deck. So you can go download it, play with it, etc. Okay, so the demo I'm going to show takes this very same use case, marketing campaign planning, and I'm going to show how to solve it with CPLEX and Data Science Experience Local. So again, we put ourselves in the shoes of this person, Bob. He's a marketing campaign planner, and he wants to assign these campaigns. In this case, we gave him a budget of $25,000. And what I'm going to show you is how we would go through step 1, which is using the machine learning to predict customer behavior. In this case, he has some data to work with. Here on the left-hand side, he knows that for savings account, there's income and age. For mortgage, he has some data on existing loans and members of the household. And then finally, for pension, some information on income and age. And so he's going to use this data to predict what future customers will do. Now, once you have the future prediction, it was going to look something like in the middle. If you give that to your business user and say, here's your answer, they won't know what to do with it, right? So your next step is who exactly should get which offer, and that's where the optimization comes in. And so what I'm going to show is, again, at a very high level, that you can then, in Data Science Experience, experiment with prescriptive algorithms. What we did in this case is we wrote one greedy algorithm, which is basically a heuristic saying choose the highest revenue choice first. And then we compare that to CPLEX. And the reason we do that, number one, is of course to show that CPLEX is way more effective. It's mathematically proven that for certain formulations, it will find the possible solution. You cannot find anything better whereas greedy is a heuristic and you can miss some solutions. And so, of course, a contrived example, but CPLEX finds much higher revenue, even though it also spends more money, but that is offset with a much larger profit. All right, so I'm going to exit here and let me get to the data science experience environment. And I think see a lot more on this. My colleague Victor Torstra later today will give a very detailed technical overview of how to work with optimization into DSX. So I would encourage you to attend that as well. This is the Data Science Experience Local environment. There are many different capabilities. There's a community. You can work with published assets. You can work with many different projects that you set up in your team. There are many different tools. You can find decision optimization in there, Jupyter, RStudio, Zeppelin, modeler, SPSS modeler canvas for visual predictive modeling. You can set up different environments. So there's a tons of stuff in there, but that's not what I want to show today. I really want to focus on just this simple example, because there are a few other things I want to talk about. Okay, so this is one way to implement this model is just simply in a notebook. So what we did here, and again, you can find this notebook in GitHub, so you can download, you can import it, and you can work. So I just want to show a few key things here. So again, this is this very same use case. You our decision optimization on cloud solver solve model. We also Python API for CPLEX. It describes a bit here what you can do with optimization, gives you some background. But in essence, what this data scientist did is they started with the historic data over here, same as you saw on that slide, to then predict various customer behavior in the future. So just going to skip forward. This is what you see here. And then eventually, this will now, in the same notebook, become the input to the optimization problem. So here we're now switching to optimization. Here it will describe additional inputs you need for the optimization, like available budget, the channels, etc. First, we code up a greedy algorithm, which is a heuristic. And then we're going to call CPLEX to solve the very same problem, which is going on here. We're importing CPLEX API. And then eventually, we come up with a solution within the notebook. So scroll to the end. And so this is one work with optimization data science experience in a normal notebook environment, just by using the CPLEX API. Now, another way that you can do this with Data Science Experience Local is to use the decision optimization add-on, that tool that I showed in the menu. So I'll show you what that looks like. It looks a little bit different. So in this case, we try to make it easier so that you don't have to code as much. So in this case, we have some capabilities to add data without having to code. Basically, you just import your data set. In this case, we have a list of offers. We have some steps that you can go and prepare your data. You can edit data, you can add data, whatever you need to do. Then we basically extract the Python model from an underlying notebook that we show here. And the purpose of doing that is really it's simple reading. So you don't have to read through a ton of code to understand what the essence is of the mathematical formulation. And as you can see over here, it's a pretty simple model. I think there's about 4 constraints involved, but that's what you can see here as well. If I were to click run, it would call the CPLEX solver on the cloud. I'm not going to do that now. I've already pre-run it, and then you can go and look at the solution. Now, what I mentioned before, we might want to compare different techniques. And for that, we added this concept of scenarios. So one scenario we solve with CPLEX, and another scenario we solve with the greedy algorithm. I can go and duplicate a scenario. I can do different things with it. I can generate a Python notebook if I'm happy with my scenario and I want to add something perhaps more complex. I can also go and save this model for deployment, which will then make it available for deployment, integrate that model with whatever application you want to use. So once I have multiple scenarios, I can then use the dashboard capability compare them, to compare their performance. And so that's what's going on here. You could potentially also go to the code and edit the code directly, but you don't have to code. And I think part of why we did this was, you know, not everyone has the same skills. Some people are very good at math and they're good at coding up visuals. Some people are good at coding visuals. But the point here was, if you're very good at math, you might not want to be coding up your visuals. So we provide this no-code environment to compare scenarios. We ran the CPLEX, which is blue, the green, which is orange. We show the difference in the assignments, how many mortgages, how many pensions, savings, etc. And then more importantly, you can go to your stakeholder now, to Bob the marketing campaign planner, and you can say, okay, with CPLEX, I spend a bit more money, but you're actually going to get much higher revenue. And then eventually show them the actual assignment. So very, very quick look at what this looks like in Data Science Experience and its decision optimization add-on. And like I said, there will be some other colleagues getting into a lot more technical depth. So I want to get back to the presentation. If you're working with, most of the time, if they're working on a predictive problem, it is probably because they want to make some kind of a decision based on that prediction. So the one we just looked at was predicting marketing, the first column there. And the decision to make is actually planning which campaign goes to which client. So regardless of what function in the business you're working with, you can generate these type of solutions for more value add. So if you're predicting sales revenue, you can go and assign territories to the sales team by optimizing. In finance, predicting rates of return on a certain asset. This ties to the classical case of portfolio optimization, where you look at all your assets simultaneously and balance. And it goes, IT operations is classical, right? Predict demand and then plan operations. Many such examples. I think it's also to note that not all optimization problems need a prediction. So for example, in automotive industries where you're cutting metal shapes out of metal sheets, right? If you think of a car and the shape of a roof versus a trunk, etc., then often used to decide how to best fit those shapes on the metal sheet to minimize the waste of metal. So lots of great use cases. I wanted to mention that we either finished recently or are working on with some of our clients in the Data Science Elite team. So the first one here is Red Eléctrica España. I'm not going to read everything here, I'll leave it to you to read, but in essence, we're helping them with better planning the renewable energy. And how does this prediction and together? Well, of course, you need to predict generation, solar generation, to predict demand. And once you know those three things, optimization is used to plan how much to produce. So a very nice problem to work on. Complexity there is there's a lot of uncertainty, of course, in the wind and in the solar generation. And that's something that we can deal with stochastic or robust optimization. Another example is with Netbank. It's a big bank in South Africa. And there we're working with them to better predict faults or the failures in their ATMs so that we can better plan which custodians should deal with the maintenance, should go and fix the ATMs and when. And really the aim there is to improve their overall customer experience at the ATM. But again, you predict and then you optimize. Then another one is with Carrefour, is a very large supermarket chain in France, actually across the world. And in the we look at this interplay between predict and optimize. So there we want to help them decide where to invest in stores across the country. So we're helping them predict the revenue based on the location or what competition is in. And then based on that, we'll then recommend placements. So it's again this predict, optimize, interplay. So that leads to the question, is that all there is to it? First you predict with machine learning, then you optimize or plan with optimization. Well, no, that's not all there is to it, even though that's a bulk of what we do with these technologies, but some other things. There have been a lot of research work going on in terms of finding out how optimization can help machine learning, or machine learning algorithms can help in optimization. So I put here some links, some references that you can look at of some of the recent work there. There's also been some work going on leveraging GPUs for optimization. So as GPUs really revolutionized machine learning. It just made it so much faster. Optimization is not there yet fully, but there's a lot of work going on to see if GPUs can help run optimization faster. That said, optimization is already fast for many, many applications. How does optimization help machine learning? Well, some of the classical machine learning problems, vector machine, this is nothing new, but CPLEX is very often used to solve that problem of finding that optimal height to max between the two separated classes with a support vector machine. So again, there's a bunch of references down there for those of you who are more interested in the research side. But I think the point here is just that these technologies are really part of the same fact. So classical examples I talked about thus far in this talk, you use machine learning, big data to come up with forecasts, scenarios. You can then use deterministic optimization models to find plans and schedules, and you go execute them. But if you want to get a bit more smart about it, let's say if there's a lot of uncertainty, like the Red Electrica example I spoke about, then probably you don't want to look at just one forecast, one version of the future. You might want to look at many different ones, all with different probabilities of occurring. And then we look at techniques like Monte Carlo optimization, stochastic, robust, all designed to deal with that uncertainty in your forecasts. Because we now have access to a lot more cloud resources, a lot more computing, a lot cheaper than ever before, we can actually now very effectively deal with these type of problems that maybe 10 years ago even were very difficult to solve. So that gets a bit more advanced. And then even more advanced these days, a lot of people, a lot of clients are talking about how to bring learning into the cycle. So not only are you learning about better forecasts, better scenarios, but also bringing machine learning into how to make the optimization models learn. So over time, learn which constraints to add, which decisions are less important, more important, etc. So there's a lot of work in those areas also going on. And I think this is really also the ideal interplay between machine learning and optimization. And so I wanted to give one last example of this type of interplay. So this is a problem we worked with Dublin City on. It was about better operating their water distribution network for a neighborhood called Chapel Lizard. This is work from a few years back, but I like talking about it because I think it's really a great example of how these technologies complement each other. Now, what went on in this case was in the city of Dublin, because the pipes were very, very old, right? Some of those pipes were wooden pipes from 100 years ago. That between % of the water treated at the water purification plants was or leaked into the ground. And so this was a problem they wanted to solve quite urgently. And there's a rule of thumb saying that if you can reduce the pressure with 1% in your pipe network, then you can reduce the leakage by 1%. The answer then is, where should they put these pressure reducing valves to be able to reduce the pressure as much as possible without affecting your cup? And there's not enough water coming out. Now, what made this a very challenging problem was the demand in that neighborhood was very unstable, because there were these large industries that would at any time just draw out a lot of water, and it would really, not only did we have to decide where to put these valves, but we also had to consider the fact that that there's this instability in the system. And for that, of predicting different types of demand profiles combined with a robust optimization approach turned out to be the ideal solution to reduce leakage. And so we came up with, I'll fast forward to this type of graphic their planners could use in their decision making. So what's going on here? Very, very busy. What we did here is we constructed about 60 possible scenarios of what that demand could be. So each of these columns across is a different scenario. And then we came up with different plans should be placed. So in the bottom of this graphic, the last 10 plans, we used a deterministic optimization approach. What that means is we assume this demand to be served like one demand forecast, and we assume it's going to be the real forecast, and we plan. We see what's going to happen if another demand turns out to be true. So for example, let's say in this block, we forecasted the demand's going to be 40. We plan for it to be 40. It turns out to be 40. It's all green. It's wonderful. But what if it turned out to be 100? Now the plan breaks. And that's where you see these red blocks. So that's what we're conveying here is, depending on the planning approach, you could have a very good plan or a very bad plan. Now, what we also wanted to show was now when you bring robust techniques into the picture, that's the top 10, you're able to deal with this uncertainty. So it turned out this was a very unstable system. And if we use these robust techniques, you can see a lot more green. And now the planner could decide, okay, in the end, they wanted to use this plan with the orange rectangle around because it's green most of the time. It shows most of the time it's going to have very good leakage reduction. And it's only going to fail scenarios, and it's such a minor failure, as you can see with the light pink color, that it's not really a big deal for them. If it were an emergency hospital, though, they take the next plan, which is always green. The KPI is not as good because it's a more dull green, but it will never fail. So this is really a way that you're effectively combining prediction and optimization. And I think the important point here is we didn't look at one prediction. Whenever you have uncertainty in your system, it's important to consider many or to consider of variability in your prediction. And that then feeds into robust or stochastic optimization to get you the best possible plan. Now, what we foresee in the future is that the decision-making systems, in this case, we had a human looking at this graphic and deciding which plan to use. But of course, we want to have this a process where it learns in time, which just implement that approach. All right, so winding down here, just talking a little bit of what is in the decision optimization portfolio in IBM. So we basically have these three main offerings. There's the core CPLEX, which is really the core for operations research experts. It has the CPLEX engines, it has various APIs, it has our own proprietary OPL modeling language, which is a declarative language. And that CPLEX engine actually exists in all our offerings. So we have that same CPLEX on cloud that you see there in the middle, which is basically sitting on IBM soft layer. So if you want to outsource your computation, that is a very good solution. And then very new, earlier this year, decision optimization for Data Science Experience, which I think we're very happy about because it's really the offering that brings now together machine learning and optimization in one team environment. And I think that's where a lot of the clients see the benefit is you don't have to work with two different tools, different data, it's all in the same place and easy to work with. Now, the portfolio, of course, integrates with many other solutions in IBM, but just to name a few, I mentioned the Data Science Experience, but of course also Planning Analytics, which often as a business front end. It's in the cloud catalog, meaning you can integrate with anything else. And the CPLEX node also exists in modular canvas. Now, there's also many other solutions where CPLEX exists in IBM, but these just name a few of the other analytics tools. And then just introducing the team that I'm part of. So we're called the Data Science Elite team, and created in October last year, really with the purpose of helping our clients jump out their data science projects. So either it's a team that is starting out in data science and we can help them come up with a use that's going to show a quick ROI, quick fit for their business, to help them expand their data science program. Sometimes it's even a client, and there we're helping, showing them how a new technology could be used, how we could bring their machine learning and optimization capabilities together. This is free. We don't charge for it. We consider it an investment in our clients. And yeah, basically the idea is just we want to help people be successful with data science. So if you are working for a client, if you're interested in finding out more, you can either talk with your own IBM representative, but you also all have, I think, my contact through this webinar, and I can help you. Okay, and then very finally, so for those of you who are new to decision optimization, there is a free course, the first link there, cognitiveclass.ai. If you want to know more about the Elite team, is the second link. And then I also listed some decision optimization resources there. You can see there our webpage that lists all. There's the GitHub link. I think there's dozens of examples of optimization, practical optimization models in just about every industry, every domain that you can find there. And some free download of CPLEX and some other things there, as well as some hashtags in the conversation. And then, of course, there you see the link to Data Science Community, where we can also continue the conversation. Okay, so there was one question about, can we watch these videos from the beginning? Yes, all the videos are recorded and they will be available after the fact. There was a question about, can we download the software? So I think it depends on which software, but for example, CPLEX has a community edition that you can go download online. The link is in the last slide and you can work with it. Data Science Experience, there's a trial version online. I think you need to search these days for Watson Studio, but it's basically the same thing. And you can sign up online for a trial version on cloud. The decision optimization for DSX is part of Data Science Experience Local, which is the private cloud version. In time, we will bring it to the public cloud, but for now, to try it out, you will need to talk to your sales representative and somehow get a trial installation to try out. There was a question about the DSX notebook and data availability. So those notebooks are available on GitHub. The link is on the last slide and you can access them at any time. There was a question about data science certifications. And we have quite a large certification program, and I will ask the person in charge of that to share with all the information on certification. There was a question about algorithm usage. So no, this talk was at a high level. For algorithm usage, you might look at Ferenc Katai, who's our CPLEX offering manager, who also gave a talk. To be honest, I'm not sure what others, but I would suggest if you want to hear more about algorithms, just send me a note and we will, we'll arrange a session focused on algorithms. There was a question about integrating predictive models with CPLEX APIs. So that's not something I covered. My colleague, Victor Terpstra, will be having a talk later today, and he is the right person. He will talk a lot more on the technical level, and he will cover that question as well. Question about where can I watch this later on? You just go back to the community, and we're going to list all the talks on the community. There was a question about, will we receive more questions? So yes, you can post questions on the community at any time. And at least I will go check, say, once a week or so. You also have my contact. Best to ask it on the community because then everyone else can see the answer. So we're constantly monitoring the community and answering questions. There was a question about one-on-one sessions. So I have made some availability on, I think, July 31st. If I see it's full, I might make a broader time frame. But yes, there will be one-on-one sessions. And for every speaker, you'll be able to browse their availability. There was a question about what kind of data science questions does the interviewer ask. So these sessions, the one-on-one sessions, I think it's called an interview, but it's more meant as a discussion. It's more meant If you have questions for me, then we discuss and I can help answer them. In choosing who you want to talk to, so you could probably see my talk is more at a high level. I have a PhD in optimization, so I can answer a lot of optimization questions. If you want to get to the level of, which API call, how do you do callbacks in CPLEX, that's not for me. That I will point you to one of my colleagues to speak to instead. But you can still let me know, okay, this is what I want to talk to about, and I can point you in the right direction. Someone said, can we add you on LinkedIn? I would be very happy to connect with all of you on LinkedIn. So I am on LinkedIn, pretty easy to find, Susara van Den Heever, and would be very happy to connect. There was a question about, can you integrate CPLEX into web and mobile apps? Yes, you can. There's a very nice demo. If you Google CPLEX ambulances, and I also have the link on the last slide, there's a little tutorial about how to make a very simple web app with CPLEX. It can get arbitrarily complex, but CPLEX has many different APIs, Python, Java, C++, .NET, REST API with the cloud offering. So it's almost the sky's the limit with what you can do with it. There was a question about math needed for deep learning, and that I would actually give to a different colleague to answer. Deep learning is not my expertise, but I believe there will be other talks on that today. So again, thank you to everyone who attended the talk. Thank you for your very, very good, interesting questions. And I hope that we will be able to continue this discussion. So thanks so much.